Hello, welcome to AstroNaught. Today we're talking about one of the main ways to detect exoplanets, transit.
I feel like an astronaut in what you know about rolling down in the deep.
The word transit just means to move through or across a space. This is exactly what planets do. As a planet rotates around the side of a star that is facing Earth, we see it pass in front of the star. Now, remember that stars are trillions of kilometers away, so we do not see the exoplanet with our naked eye. Instead, we observe the light curve of the star. The luminosity and distance of the star will determine how bright the star appears from Earth, which we can detect via spectroscopy, the measurement of spectra. As we gather incoming data, we can look at how the brightness of the star changes with time. If nothing is in front of the star, from our line of sight, the brightness of the star will remain fairly constant. There will be some variations in the star's brightness if the star pulsates or has star spots, but the overall trend is constant. Real data is messy. As a planet passes in front of the star, it will block some of the star's light we observe and cause a dip in the brightness curve. The size of the dip will depend on how large the planet is compared to the star. If the planet is large compared to the star, the dip will be deeper. If the planet is small compared to the star, the dip will be shallower. By detecting a transit, we can learn not only about the existence of a planet, but also about the characteristics of the planet and the star. The depth of the transit is equal to the radius of the planet over the radius of the star, squared. This means that if we know the radius of the star, we can derive the radius of the planet. The amount of time it takes for a planet to start transit again is the planet's orbital period. If we know the period, we can use Kepler's third law to calculate the semi-major axis of the orbit. Most exoplanets are discovered via transit. However, there are a lot of planets that are undetectable by transit because they are either too small relative to their hosts, or their orbit is not within our line of sight. Other ways to detect planets include tracking radial velocity, in which we notice a star shifting back and forth due to the motion of a planet, direct imaging, and gravitational lensing. Well, that's pretty much all for today, so thanks for watching, and as always, ponder, wander, and go right in the stars.
In slow motion, yeah. I feel like an astronaut in the ocean. Like what you know about rolling